In this example, we're asked to calculate the mass of the precipitate if 25 mils of calcium chloride solution at this concentration is added to 56.5 mils of mercury 1 nitrate at its concentration. We need to recognize here we are given information for both reactants. This means we need to find the limiting reactant. Starting off then, Stoich, we always find our balanced chemical equation first. We've got calcium chloride, which is aqueous, reacting with mercury 1 nitrate, so it's HgNO3. That is aqueous. That is going to produce, again, double displacement, so we're going to get calcium nitrate, which is aqueous, and mercury chloride, which is our precipitate. Balancing then, we need a 2 in front of the mercury 1 nitrate, and we need a 2 in front of the mercury 1 chloride. Everything else then is balanced. Step 2, we're going to find the moles of both of our reactants first, and then we're going to use those in mole ratios to figure out which one is our limiting reactant. So let's start with calcium chloride. The moles of calcium chloride, we are given a volume and a concentration, so we're going to use C times V. What do we got here? We got 0.085 moles per liter times 25 mils, which is 0.02500 liters. That gives us 0.00212 moles of calcium chloride. For the moles of, what's our other one? Our mercury 1 nitrate. Same thing, we're given a concentration and volume, so we're going to take concentration times its volume, 0.10 mole per liter, times 0.0565 liters. That gives us 0.00565 moles of silver 1 nitrate. Let's then now set up our mole ratios for both to find out which one is limiting. Starting with calcium chloride, we've got 1 mole of calcium chloride from our balanced chemical equation reacts to give 2 moles of mercury 1 chloride. We figured out we had 0.00212 moles of calcium chloride. We're trying to find the moles of mercury 1 chloride. Solving this then gives us 0.0042 ... moles of mercury chloride, 1 chloride. Okay, so that's our calcium chloride. If we do the same thing with our mercury 1 nitrate, if we set up the mole ratio, you're going to notice that it's a 1-to-1 ratio. That means that the number of moles of mercury 1 chloride that we produce is going to be the same as the number of moles of mercury 1 nitrate that we start with. So the number of moles that we get is also 0.00565 moles of mercury 1 chloride. If we take a look then, this one here from the calcium chloride is the smallest, so this is our limiting reactant. That means that the mercury nitrate is in excess. Now that we know our limiting reactant, we can use that to find the mass of the the mercury 1 chloride that is formed. So we're going to take mass as moles times molar mass. And we're going to use the number of moles from our mole ratio using calcium chloride because that is our limiting reactant. So we've got 0.0042 ... moles of mercury 1 chloride that is formed times the molar mass of mercury 1 chloride, which is 236.04 grams per mole. This then gives us 1.00317 ... grams. So rounding that off to significant digits, we should have 2 significant digits, which means that 1.0 grams of the precipitate, which is mercury 1 chloride, is formed.